Very good afternoon, all of you. Today morning we discussed how to fit a linear curve, that is y is equal to a plus bx. Along with that, we saw some special cases of the equation with certain modification that can be converted to the linear form. In this particular session, we will discuss exponential or power equation, and along with that, we will also see second degree parabola, how we can fit the data to the required form of the curve. So we'll start with exponential or power equation. So generally, let's consider this first equation, y is equal to a x raised to b. So this is the one form of exponential or power equation. So when we go for solving such type of equation, we need to linearize the same. So if we take the logarithm on both sides of the equation, then it can be linearized. So after taking log, y will become log to the base 10 y, a will become log to the base 10 a, plus b log to the base 10 x. So this is the linearized form of this equation. Now in this linearized form, we can put log to the base 10 y is equal to capital Y, log to the base 10 a is equal to capital A, and log to the base 10 as capital X. So when you put all these values in this equation, we will convert that equation into a linear form, that is y is equal to a plus bx. And here, once you solve this equation, just use this equation to calculate the value of small a. So that can be done. And when you put that small a back to this equation number 1, we will get the required power or exponential equation. So this is the method where we take a logarithm on for the given equation to linearize it. Let's take another equation, y is equal to a e raised to bx. So again, in this equation also, we need to take the logarithm on both sides. So when you take the log, y will become log to the base 10 y, which is equal to log to the base 10 a, and b x log to the base 10 e. Now we will put log to the base 10 y equal to capital Y, log to the base 10 a is equal to capital A, and b log to the base e, log to the base 10 e equal to capital B in this equation. So when you put all these things in the equation, again you will get a linearized equation, y is equal to a plus bx. And furthermore, the value of a as well as b can be calculated from capital A and capital B. That we have already prepared the equations. So you can see here. Similarly, there could be a third type of equation, x y raised to a equal to b. So this is another equation. Sometime, especially in cutting tool, you might have seen this equation, p v raised to gamma equal to k. So again, in this equation, we take log. So equation will become, x will become log to the base 10 x, y raised to a becomes a log to the base 10 y, and b will, yes?
So please, you could start the record.
Can you repeat your question?
Sir, please start the.
I guess on other class I already started the recording.
Yes,
Okay, I will just confirm. Yeah, for T A division, the recording has already started. Okay.
please.
Okay, great. Okay, so we were here. So just a minute. Yeah, so we will take the logarithm on both sides of this equation. Just a minute, I guess there is some problem. Yeah, so we will take logarithm on both sides of equation 3. So x will become log to the base 10x, y raised to a will become a log to the base 10 y, and b will become log to the base 10 b. Then in that equation we will we will rewrite the equation. So we will take log to the base 10 y on one side and remaining terms on other side. So log to the base 10 y has a multiplication factor of a. So when it will go to other side, it will become 1 by a. And then you can see log to the base 10 b, again minus 1 upon a, log to the base 10 x. So just simply we rearrange the term. The ultimate aim of this to convert the given equation into a form y is equal to a plus bx. So put log to the base 10 y is equal to capital Y. 1 upon a log to the base 10 b is equal to capital A, minus 1 upon a is equal to b we can put, and log to the base 10 x is equal to capital X. So all these values we will put in this equation, and when you do that, the equation will take this form: y is equal to capital A plus capital B x. And again, small a and small b, these are the two unknowns in equation number 3. So that can be calculated from capital A and capital B. So what we have seen in this particular type of problem is that the equation will be of exponential or power type. You can see in equation 1, 2 and 3. So what we have to do, we have to take logarithm and simplify the equation. Upon simplification and rearranging the terms, you will get y is equal to a plus bx. So every time you can linearize the equation. So that step is very important in this case. And once you linearize those equations, you can use the method that we discussed, or the process that we discussed in morning lecture, and just go on applying that traditional process and you will get the solution. One additional term is that in this equation you need to check carefully a, b, and when you look at this a and b, you need to see how we can convert the capital A to small a, and here also you can calculate the values of small a and small b by using the capital A and capital B and associated equation. That back substitution is also very important. Generally in the examination, student forgot to do the back substitution. If they get the value of capital A and capital B, they think that the answer is there, but that is not the case. So the back substitution is also very important. Ultimately what we have to do, we have to find out the value of a and b in all these equations, and here a and b are in small a and b. So once you get it, put back to those equations and rewrite those equations. That will be the answer. Sometime you may be asked to find out the value of y for given value of x as well. So that additional steps you need to perform in some of the cases. Okay, now let's take one example. An experimental data on lifetime t of a cutting tool at different cutting speed v is given in table. Fit the curve of the form v is equal to a t raised to b. So in the table you can see the speed is given, 5 values of t, that is cutting speed, and the life of the tool is given, and for corresponding v you can see the corresponding t is there in the table. So 5 data points are there, and you need to fit this curve v is equal to a t raised to b. So as I mentioned, you can either go with this equation where v and t are variables, or you can convert this to v can be replaced by y and t can be replaced by x. So that is up to you how you can proceed. So in this particular example, we will convert the power function v is equal to a t raised to b to y is equal to a plus bx. And for that we will take logarithm of this equation. When you take log, v will become log to the base 10 base ev. So you may ask one question. In previous slide we took log to the base 10 and here we are taking log to the base e. So that is up to you. You can take suitable logarithm and you can proceed. So here log to the base 10 e v is equal to a become log to the base e a plus b log t. So this is the simplified version. Again, in this equation, we will put log to the base log v is equal to y, log a is equal to a, and log t is equal to capital X. When you do that, you will get y is equal to a plus bx. So this is the linearization of this non-linear curve. Linearization of the curve. So this is we did here. Now for this normal equation, these are the for the given linearized equation y is equal to a plus bx, these are the two normal equations. And here important thing is that while writing the normal equations, make sure that you are taking capital A and small b based on the given equation. So that care you need to take care of. So here two equations, two unknowns. Now we need to prepare a table through which we can calculate summation y, summation x, summation xy, and summation x square. So you need to prepare the table carefully. In column number 1, you need to put the values of t. So you can see here t. Then in second column, you need to put the value of v. So here the confusing thing is that generally the v is given in latter part and t is given in first part or first and second row correspondingly. But here we need to find out which is independent and which is dependent. So the lifetime depends on the cutting speed. So that's why we are taking t here and v here. Or you can go in any way, that depends on you. So the values of t are 75, 30, 10, 7 and 5. So we entered the value correctly in the table. Similarly, v 325, 375, 450, 475, 500, correct. Now, previously we saw that capital X is nothing but log t, where the base is e. So you need to do that operation and find out the value of capital X. So you can also check whether I correctly estimated this value or not. So log to the base e 75 will become 4.3175. Log to the base e 30 will become 3.4012, and similarly you can calculate the remaining values of capital X by using this formula. Then we need to calculate the value of capital Y, and here we already derived that equation, log to the base e v. So log to the base e 325 will become 5.7838. Log to the base e 375 will be 5.9269. And similarly you can calculate the remaining values of capital Y. Here I strongly recommend you to check the values of capital X and capital Y if I estimated correctly, because during calculation I might have done some mistake. So you need to be very careful and check the answers for all the values. Then we calculated capital X, capital Y, then we can calculate square x square. So that process is very simple and you can do it at your own as well. So square of x, first value, that is 4.3175 square, will be 18.64007. Similarly, the square of 3.4012 is 11.5681. And similarly, you can calculate the values for the remaining rows. Then you can also take the product of x and y to prepare last column. So take the product of x and y and prepare this value. For example, the product of 4.3175 multiplied by 5.7838, it will be 24.9716. And here you can see 20.1586. And similarly, you can calculate the other values. Once you do it, you will get the value of summation x as 13.5766. Summation y is 30.1979. Summation of x square is 41.8876. And summation xy is 81.1926. So just take the sum of the values of x to get its summation. Similarly, you can take the summation of y, summation of x square, and summation of xy. So this is the very interesting process where you can calculate all the unknowns from the normal equations. So I just repeated those values. Now put these values in first normal equation. When you put it, the number of unknowns are 5, so n is equal to 5. A is constant, unknown, B is unknown, and summation x is 13.5766. Similarly, summation y is 30.1979. So just simplify this equation. Upon simplification, you will get 5a plus 13.5766b equal to 30.197, and let's call it equation number 1. Similarly, in second normal equation, you need to put all the values where a is unknown. So you can see here I made a mistake. So this should be capital A. Summation x is 13.5766, b unknown, summation x square is 41.8876, and summation xy is 81.1926. And simplify this equation. Upon simplification, you will get 13.5766a plus 41.8876b equal to 81.1926. Let's call this as equation number 2. So we have now two equations and two unknowns, capital A and small b. So you can apply any suitable method to solve simultaneous equations, and upon that you will get the value of capital A as 6.4744, b is equal to minus 0.1601, and once you get the value of capital A and small b, this is small b. So when you do that, you can use this equation to calculate the value of small a, because in previous slide we saw that we derived the equation for capital A, and that is log to the base e a, and now you need to simplify this equation in terms of small a and put the value of a. So when you do that, you will get the value of a as 648.3301, and now you have a value of small a and small b. So put that into given equation, and upon that you will get v is equal to 648.3301 t t raised to minus 0.1601. So this is how we first of all linearize the non-linear equation. That non-linear equation is also called as exponential or power equation in this particular type of problem. Once you linearize it, you need to prepare the table for calculating the unknowns from the normal equation. Put those values in the normal equations. You will get equation 1 and equation B. These are the two simultaneous equations, and you are free to use any suitable method to calculate unknown. And once you calculate unknown, you will get value of capital A and small b in this case. And we know that in actual equation, we have to put the value of small a, and we know the value of capital A. So use this equation, go on simplifying, and upon simplification you will get value of small a. Put back the value of A and B in the main equation, you will get the required power equation or power function. So this is how we can solve problems related to exponential or power functions. Now one more equation we will see here, fitting a second degree parabola. So in case of linear equation, we saw that the equation was y is equal to a plus bx. This is the linear form of the equation. Now here we are just putting one additional term, that is cx square. So the equation will become second degree parabola. So that equation is y is equal to a plus bx plus cx square. Let's call this as a equation number 1. And the process is almost similar that we already discussed. So how to solve such type of problem? The values of x and y, that is data points, will be given to you as x1, y1, x2, y2, x3, y2, and so on. And here you can see the last values are x and y, and so the total number of data points will be n. And in the given problem, you can simply count the number of data points, and that will be your value n. Once you do that, as in equation number 1, there are three unknowns, A, B, and C. So here we need three simultaneous equations. So equation number 1 is summation y is equal to na plus b summation x plus c summation x square. Second normal equation is summation xy plus b summation x plus c summation a summation x plus b summation x square plus c summation x cube. And third equation is x square y, which is equal to a summation x square plus b summation x cube plus c summation x raised to 4. Now in case of linear equation, we have seen only two normal equations, and you can see I have bracketed some part of these normal equations, and the bracketed part will be the two normal equations which we already use for linear type of problem, that is summation y is equal to na b summation x and summation xy is equal to a summation x plus b summation x square. Now when you compare these three equations, then logically you will come to know how we can memorize this formula. So in equation number 1, na plus b summation x plus c summation x square. So here term x is there and later it is x square. Now when you go to second equation, instead of na it is a summation x. So instead of b there is a and summation x is there. Again here instead of c it is b and summation x square is there, and plus you will see c summation x cube. This additional term will be there when there are three unknowns. Similarly in equation number 3 you can see a summation x square. So summation x will become x square, summation x square will become summation x cube, and summation x cube will become summation x raised to 4. So this is how you can easily memorize these three formulae, because in the examination these formulae will not be given to you, and from understanding point of view very easy. Now in equation number 1 we know that there are three unknowns, and that's why we prepared three normal equations. And once you calculate the summation values, then you will get three equations, and in all the three equations there will be three unknowns a, b and c. So three equations, three unknowns, you can solve this simultaneous equation, you will get value of a, b and c. Once you get the value of a, b and c, put those values in equation number 1 and you will get the required second degree parabolic equation. So this is how we solve the problem. So second degree parabola equation will be given to you. Data will be given to you. From data you can calculate how many data points are there. That will be n. Then in the equation three unknowns, so you need to write three equations. Once you write three equations, calculate the summation part. Once you calculate those values, you will get three equations and three unknowns. So that will be a simultaneous equations. So solve this simultaneous equation by using any suitable method. You will get value of a, b and c. Put back those values in equation number 1 and you will get required values. Now we will see one example. Now here three equations and there are so many unknowns that you need to calculate. So you should be preparing the table and doing calculations very carefully. During this process there is a chance of mistake. So we will take one example. Fit a second degree parabola to the following data. So the value of x and y are given to you. Now we know that in this problem the second degree parabola equation is not given to you, and here you need to write that equation. Y is equal to a plus bx plus c x square. So you need to memorize this equation, right? Now once you do that, you need to go ahead. So number of data points are 5, so n equal to 5. Now for parabolic equation there are three unknowns, so we need to write three normal equations. So these are the three equations that we already seen in previous slide. And now when we look at this equation, you need to find out the values of summation y, n, summation x square, summation xy, summation x square, summation x cube, summation x square y, summation x raised to 4. So you can see there are so many summations that you need to calculate, and for that you need to prepare the table very carefully. So we will go to the table. So in column number 1 write the values of x. So they are 0, 1, 2, 3, 4. In column number 2 put the values of y. 1, 2, 3, 5, 7, correct. Then complete third column, that is x square. So 0 square 0, 1 square 1, square of 2 is 4, square of 3 is 9, square of 4 is 16. And then you can go for fourth column where you need to find out the product of xy. So product of 0 and 1 is 0, 1 and 2 is 2, 2 and 3 is 6, 3 and 5 is 15, 4 and 7 is 28. So this is how you can complete column number 4. Then in column number 5th, you need to find out x cube. So cube of 0 is 0, cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, and cube of 4 is 64. Then Next unknown is x square y. So x square y, that is, you can see column number 2 and 3. 1 into 0 is 0, 2 into 1 is 2, 3 into 4 is 12, 5 into 9 is 45, 7 into 16 is 112. And in last column, x raised to 4. So 0 raised to 4, 0, 1 raised to 4, 1, 2 raised to 4, 16, 3 raised to 4, 81, and 4 raised to 4, 256. So when you look at all the columns and if you compare with all normal equations, then you may see that you will get all the values of unknowns, that is summation x is equal to 10, summation y is equal to 18, summation x square is equal to 30, summation xy is 51, summation x cube is 100, summation x square y is 171, and summation x raised to 4 is 354. So now you have all the values and that you can put in the normal equations. So I'm just repeating the values here. Now we will go for first normal equation, summation y is equal to na plus b summation x plus c summation x square. So n is the number of data points, which is 5, a unknown, b unknown, summation x is 10, c is unknown, summation x square is 30, and summation y is 18. So we put all the values in that equation, and upon simplification you will get 5a plus 10b plus 30c equal to 18, and let's call this as a equation number 1. Then we go to second normal equation where a is unknown, the value of summation x is 10, b is unknown, summation x square is 30, c is unknown, summation x cube is 100, and summation xy is 51. So put all the values and simplify the equation. Upon simplification you will get 10a plus 30b plus 100c equal to 51. Let's call this as a equation number 2. Then you need to repeat the same process for third normal equation, where you need to put all the values. You can see x square, summation x square 30, summation x cube is 100, summation x raised to 4 is 351, and summation x square y is 171. Simplify, you will get 30a plus 100b plus 354c equal to 171. Let's call this as a equation number 3. Now here we have three equations, equation 1, 2, and 3, and we have three unknowns a, b, and c, and this is the case of simultaneous equations. So now you can realize that here you need to use one of the method of solving simultaneous equation that we already discussed in unit number 1, and you need to apply suitable method and solve. That will take time, and this will be a good practice to solve the problems from unit number 1 as well. So you can see the application of simultaneous equation you can see in unit number 3, and even in real life, as I already told in the 2 lectures back, that in so many real life you need to fit a second degree parabolic curve, and there you will get these equations, equation 1, 2, 3 like this, and you need to apply again simultaneous equation to solve the same. So upon simplification, here I didn't do that step because you already studied and you can do it. And examination, you need to solve these 3 equations and write its simplification. Here I didn't do it because you already know it. Now when you solve these 3 equations, you will get the value of a as 1.0286, B equal to 0.6429, and C equal to 0.2143. Here I would like to tell you one thing. Suppose in SEM or in final examination, if it is online and if this type of complex equation is asked, so how you can solve? You have an option. You already have Python code for solving simultaneous equations. So what you need to do? You need to just put the values of equation 1, 2, 3 in the Python code, and directly you will get the value of A, B, and C. So that trick you can use to solve the given problem in less time. So this is how we can calculate the value of A, B, and C. Then we need to put back the value of A, B, and C in equation in the second degree parabolic equation, that is y is equal to A plus bx plus cx square, where A is 1.0286, B is 0.6429, and C is 0.2143. So that's it from my side. So if you have any question, the session is open for discussion. Yes, any question?